So you should have the spotlight now, Elena. So this is Elena from Roboception, and they're going to introduce to you their robot solution.
Thank you, Penny, and hello everyone. My name is Elena Gambaro, and I'm a software developer with Roboception, and also product owner of the CADMatch software that we'll be showing today. Penny, I cannot share my screen. This is disabled.
You should have access now. Apologies for that.
No problem. Okay, so I'm just gonna give you, first of all, a very short presentation about our company and our product, and then we are moving on to the live demo. So first of all, our company profile. Roboception was founded in March 2015 by 3 former employees of the German Aerospace Center. KUKA Deutschland is a shareholder of our company since August 2015. We are based in Munich, close to Pasing train station, and at the moment we are 18 employees. At Roboception, we bring eyes and brains to robots. To give you an idea of how we do that, you can have a look at the image on the left here, where we have a classic industrial automation production with robots, in which robots are moving to predefined locations, which are taught offline, and there is very little flexibility to that. With the new production concepts that are developing right now, especially, as you of course know, in automotive and electromobility, this poses several challenges, and we try to address them with our customers. In addition to industrial automation, we are also working in logistics. There, the challenge is that there are thousands of different parts coming to the cell, and they need to pick and place, for example, from one tote to the next one. And at the moment, in this domain, there are only few robots, and this is still a really manual job because of the flexibility that it requires. So at Roboception, we help customers in logistics and industrial automation to flexibly automate their production. How do we achieve that? This is our product portfolio. You can start from the bottom, you can see our hardware. First of all, the RC Wizard sensor family. The RC Wizard is a stereo-based 3D vision system with onboard computing. We offer that with a standard software package in different baselines in color and monochrome. For some time-critical application, we found out the onboard computing on the RC Wizard is not enough, and for that we developed the RC Cube, which offers the same interface as the RC Wizard, just with the advantage of additional computing resources. On top of the hardware, we have our software, what we call RC Reason, which is a modular software suite with different modules, each one solving a specific application. For example, we have Tag Detect for detection and localization of markers, the SLAM module for navigation application with mobile robots. I didn't mention that before, but the RC Wizard also has an onboard IMU, and we combine the data from the IMU with the images to achieve and to estimate the ego motion of the sensor in real time with 200 Hz. And in this way, we can enable these navigation applications. The next 2 products, item-pick and box-pick, are our product for the logistic domain. For item-pick, we have unknown objects, so we don't know what's coming under the camera. We just know that we need to pick one or more of these objects from the bin. While box-pick is our product for the palletizing and depalletizing, so with box and rectangular shaped items. The next 2 modules, Silhouette Match and CAD-Match, are product for industrial automation. For Silhouette Match, we have the requirement that the objects needs to be lying on a plane, while for CAD-Match, we remove that requirement, meaning that the object can be in one bin with any kind of orientation. For application that we cannot solve with the standard software modules, we also develop customer-specific solutions using AI with our customers. Going into a bit more details about CAD-Match, as I mentioned before, this is a product for robotic machine tending application. So we can detect position and orientation of objects using a CAD model. In the rendering here, this is a standard application. You can see the RC wizard connected to the RC cube as the module runs off board on the RC cube, and then a sample scene with some objects inside a bin. For the current module, we require the objects to be of the same type. And then using our software, we can detect the object, we can teach grasps on the objects, and the robot program will get these grasps in the robot base frame and can directly pick the object. And in this case, for example, load a machine. And I'm going to show you live in a minute this whole procedure. How do we configure a new CAD model and with the robot pointing to the device, to the objects for grasping. But before that, this is an overview of how the detection in CADMatch works. So we have a two-stage pipelines. In the first stage, we do object detection and pose estimation using machine learning, so using a convolutional neural network. And as you probably know, one of the main problems with machine learning is the training part, because it requires a lot of data. And for CADMatch, we actually only use simulation images, so there is no manual labeling required. In the second stage, since from the neural network, we don't get a pose which is accurate enough for picking, we do a refinement of the objects using an edge alignment algorithm, which brings us to the accuracy that we need for picking and placing the parts. This slide is about how do we train the neural network. So how do we generate what we call a template from a CAD model. When we get the CAD model from the customer, we put this object into a photorealistic simulation environment, and we generate images similar to the ones that you see here on the right. We do have a large material library that gives us robustness against the lighting conditions and also the color response, meaning that we don't need to know how the object looks like in reality, but we can just simulate multiple materials, and the network learns to be independent of the material and just learns the relevant information, which is the shape of the object. At the moment, this training procedure is not parallelized, so we have running it on one single GPU, and it takes 6 to 7 hours, but it's completely automated, so it's running overnight on our servers. The advantage of having a simulation is that we can also, for each part that we get from a customer, estimate the accuracy with which we can detect the part. To do so, we simulate the left and right images with our simulation tool, and then we feed them to our stereo algorithm, which generate a point cloud which has all the defects and deformation that are there in real images. We detect then the objects in this point cloud, and since from the simulation we know the original position and orientation of each object, we can estimate an accuracy. At the moment, depending on the part, we have an estimated accuracy of 1 millimeter in position and below 5 degrees in orientation. Good. This was a quick introduction to our CADMatch module, and now we can move on to the live part of the demo. Let me share the screen. Good. So now I'm connected to the RC Cube web GUI of the sensor that we have here in our lab. From here you can see we have a visualization from the web GUI of left and right camera images that are coming from the sensor. Since the system offers a web interface, you actually don't need to install anything on your device to visualize images and to actually try out the module. We also have the possibility to visualize the 3D image. At the moment, this is running in a single frame mode, which means we acquire images only when we require to. And this has the advantage to reduce latency for the detection, but we can also offer, of course, a continuous acquisition mode. Moving on to the CADMatch module, Now I'm assuming we got a template, so I will load this template for the part that you see in the image to the web GUI. Here it goes. I call it CADMatch demo, and this is uploading now to the RC Cube. Once the upload is done, I have a 3D visualization of the object in which I can teach some grasps. For example, I'm just putting a few grasps on this part. At the moment, I'm assuming that we are going to use a device which grasps from the surface. So I'm just placing the grasp on the surface of the object. Of course, if you would have two-finger gripper and effector, you would need to shift probably the grasp to the center to represent the robot tool center point. And I'm adding one more on this side. You can also, of course, move them if the position is not good enough for your application. And one of the advantages of our module is that we can handle symmetries in the object internally. So we have the option to visualize symmetric grasps when we do have them, so that during the detection, we can also pick and project the best grasps on the objects. Now that the CADMatch is uploaded, we can actually try out our detection. Here in the tryout section, we can specify the template that we want to detect. The load carrier is the container in which the objects are inside. This is optional. In this case, we do have a container with these dimensions. Specifying the container is quite easy. You just need to enter the outer and inner dimension that you can get from the container manufacturer. Additionally, we also have the option to specify a collision model for our gripper, so that the module can also check between collisions between, for example, the walls of the tote and the object themselves. So in this case, on our device, we have mounted a pointing device, which I can specify here. Now we can run the detection. We can specify the amount of objects that we want to detect. Here you can see a 2D visualization with the detected objects marked in red with a number. And we also have a 3D visualization here that shows the detected objects and the grasps on these objects. Yeah, so we are sorting the grasps, for example, in this case, according to the detection. So how good the detection was on each single object, and using what we called, and you can see here, a preferred orientation, meaning the preferred orientation of the gripper for approaching the object themselves. Good. So this is everything we can do from the web GUI and try out and configuring our part. Now we can move to the actual picking of the object with a live stream. Yeah, a colleague of mine is helping us today with the demo and is running the robot application. In this case, as you can see here, we have our gripper with a pointing device that we use for accuracy evaluation. So we will not grasp the objects today, but we will prove with the orientation of the program how well the detection works. And yeah, we are starting the demo right now. Yeah, just to prove that parts are randomly placed in the bin. And from the robot program, we can trigger the detection, selecting the same parameters that we configured before. And here we are moving with the pointing device to the detected objects. For this demo, at the moment, we are just moving to all detected grasps, one after the other. Of course, the speed is not it's quite slow at the moment because we don't have any fences. So this lab is an open space and we cannot move faster for now. We can also have a look while the demo runs at the 3D visualization here, which is basically now the detection is triggered again. And while the robot program runs, we can have a look at the visualization of the parts so we can predict where the gripper will be moving to the objects and so on. yeah, we can have the program keep running multiple times. Yeah, this was a quick overview of our CADMatch module. Yeah, it was really nice to be presenting that today, and I'm looking forward to your questions.
Fantastic. Thank you, Elena, for that. Oh, that was brilliant. Nice to see it all in action. Really, really cool.